Hello everyone, I am Tushar DM, 1B at 22 CS 174, 5th semester C-section student of Computer Science Department at Bangalore Institute of Technology, Bangalore. And today I'm going to present you on how to use the JFLAP tool for the subject Theory of Computation. So initially we have to have the JFLAP desktop application. So open the web browser, then just type JFLAP. So here just click on the JFLAP software. So here you will be getting the latest versions of the JFLAP tool be downloaded on your particular system. Download the respective one, the latest one. So this is a .jar file. So the prerequisite is to have the JDK installed over your system. Upon downloading, just double tap over this one so that you will be redirected to the actual tool. So let us first do the finite automata simulation. So I'm going to do a problem over deterministic finite automata, that is DFA to accept the strings of A's and B's that are ending with ABB. So the basic minimum string is ABB. So we have to have four basic states: Q0, Q1, Q2, and Q3, where Q0 will be our initial state and Q3 will be our final state. So we have to give the transition from Q0 to Q1 or the input symbol A, from Q1 to Q2 or the input symbol B, from Q2 to Q3 or the input symbol B. So this is the basic machine that will be accepting the minimum string ABB. So for the state Q0, we are having transition upon the input symbol A. So on the input symbol B, we have to give a self transition. So for the state Q1, we are having a transition over the input symbol B. We need to give transition over the input symbol A. If we give a self transition on the input symbol A, the strings that are ending with ABB will be accepted. For the state Q2, we need to give transition over the input symbol A. So if we give a self transition over here, the strings that will be ending with B's, multiple A's and B's will be there. So which is not acceptable, which is not a requirement. So we have to remove that one and we have to try out any of the back transitions. So let me try with the Q2 to Q1 as a back transition or the input symbol A. So if I give a back transition from Q2 to Q1, we will be having BA, multiple BAs. So then we will be having BAs, that is B A. Then again we'll be having BB, that is ABB at the end, which will be accepted. So next for the state Q3, we are not having any transition or the input symbol A or B. So let me try out with the input symbol A. So if I give a self transition or the input symbol A, the strings will be ending with A, which is not acceptable. So we can't have that. So for the next one, let me try out with the Q3 to Q2 or the input symbol A. So this one will be ending with BAB. So BAB, which is not our requirement. So we have to ignore this transition. We can't give that. So let me try out with the Q3 to Q1 or the input symbol A. So this one will be ending with ABB. Like if we come back A, then BB, which is a possibility. So let me just relay out this one properly in order to have a better visualization. So yes. So this is the transition or the input symbol A for the state Q3. So that's a back transition from Q3 to Q1. So for the next transition is like or the input symbol B for the state Q3. If I give a self transition over here, it will be ending with multiple B's, which is not a requirement. So we have to remove that. So then let us try out with the back transition from Q3 to Q2. So if this is the case, this one will be ending with the same thing, multiple B's, which is not the requirement. So then let us try out with the back transition from Q3 to Q1. So this one will be like B, B, A, B, and like it will be ending with B, but we can have like multiple A's or B's and then BB, which is not the actual case. So we have to remove that one. Then let us try out with the back transition from Q3 to Q0. So this one will suffice as it will be ending with ABB. Then let us just relay out this one. Yes. So here we are having this. So this is what the DFA to accept the strings with A's and V's that are ending with ABB. Then let us test with some of the inputs by step tracing. Let me give the string ABABB. So as it is ending with ABB, it has to be accepted. So initially it's in the initial state Q0. Then upon receiving the character A, it will be moving to the state Q1. Then the input character is B, then it has to move to the state Q2. Then the input symbol is A, it has to move back to the Q1. Then we are having the input symbol B, it has to move to Q2. Then we are having the input symbol B, we are moving to the state Q3. And then as the string ends and it has reached the final state, the string will be accepted. So let me try out with one more input for the tracing. So let me give the input symbols. Let me input as BA, BA. Let us try it out. So the initially it's in the initial state Q0. Upon receiving the input symbol B, it will be in the same state Q0. Then upon the input symbol A, it will be moving to the state Q1. Then we are having the input symbol as B, it will be moving to the state Q2. Then we are having the character A, will be moving back to the state Q1. Then we are not having any further characters and it has not reached the final state. So it has to be rejected. So it has been rejected. So in order, and so we have showed two strings as for the tracing. One is for acceptance and one more is for the rejection. Let us save this file as DFA. DFA dot DFF. Save. That's a DFA file. So the second problem we are doing is on push down automata. So let us open the JFLAP tool and here select the push down automata for multiple character input. So here we need to design a PDA to accept a language L equal to W capital C WR, where W belongs to A comma B. So the language says that the PDA has to accept the palindromes. The W and WR are like the exactly the reverse of each other. Whereas the C, capital C acts as the midpoint for both of them. So let us have the initial state Q0. Let me mark this as the initial state. So the stack top initially will be having the Z0. So here the first character can be either A or B. So the stack top will be the Z0 here will be represented as a capital Z and the stack will be A and capital Z. So suppose the first character is B, even that's a possibility. So the transition over the input symbol B, and if the stack top is capital Z, then the stack will be B and Z. So what if there is already capital A on the stack top? And we can have like combination of A or B as the next input character. So here there will be two more combinations or the input symbol A and this, if the stack top is A, the stack will be AA. What if we are having the input as B and the stack top is A, then the stack will be BA. What if the stack top is having the input symbol B? And what if the like, so we are having two combinations like A and the stack top is B, the stack will be AB. And one more is the input symbol is A and the stack top is B, so we will be having BB. So after this one, these are the 6 different combination which we can have the different characters. So upon travel, so these can parse till the capital C. So the capital C actually defines the midpoint. So let us change the state from Q0 to Q1 over the input symbol capital C. So the input symbol is capital C, but the stack top may contain A. So what we are doing nothing. The stack top will be as it is like A. So what if the stack top is having the symbol B and there is an input symbol capital C. We are not doing anything. The stack top will be as it is. We are not deleting, we are not popping, or we are not pushing anything. What if there is nothing on the stack? That is, Z0 will be on the stack, which means that the W will be empty string, which has to get the WR to be empty string in order to be accepted. So the transition will be the capital C over the input symbol Z0. It will be same as Z0, that is capital Z. So upon crossing the input symbol capital C, we will be having the other things like if we are having A in the first part, again A has to come in the second part. So the transition will be the self transition. If the input symbol is A and the stack top is A, then we will be popping the symbol. Then if the input symbol is B and the stack top is B, then we will be popping the B. What if there are other combination? Like the actual input symbol is A, but on the stack top we are having B. So then like A and B are opposite, then it is not a palindrome. So here upon traversing all the characters, we will be having the blank state. We will be having the blank symbol. So let us give one more state, that is Q2, and let us make it as the final state. So we will be having nothing, that is empty string will be there. So let us give from Q1 to Q2 as empty string, that is lambda. The string top will stack top will be capital Z, then it will be capital Z as it is. So this is the push down automata to accept the strings, that is palindromic strings W, C, WR. So now let us check for the various input symbols, like various string tracings. So let me give the input as ABA, capital C, ABA. Then let us check out using so we can accept using the final state or empty stacks. The machine is being designed to accept by the final state. So let us select the final state. So the tracing, initially the stack top is Z. Then upon having the input symbol A, it will be in the same state Q0. The stack top will be AZ according to this transition. Then the B is there. For the input, the stack top is AZ, that is A. Over the input symbol B, the stack will be AB. Next, we are having the A. For the stack top B, then we are having AB here. So then we have got capital C. So we have changed the state from Q0 to Q1. Then we are having again A and the stack top is A. Then it will be popped. Then stack top is B and the input symbol is B. We will be popping. Stack top is A and the input symbol is A. Then we'll be popping. Then we are having nothing, that is empty string, and it will be accepted. Now again, let us check for one more symbol, one more tracing by step by step. Let me give it as BA, capital CA. As the last part, that is WR is not having BA, it should be rejected. Let us check it out. Let the PDA be accepted by the final state. So initially we are having the input symbol B, it will be in the same state Q0. Then we are having A, it will be in the same state, and the stack will be A, B, Z. Then upon receiving the input symbol capital C, it will be changing the state from Q0 to Q1. Then upon receiving the input symbol A, as the stack top was A, it has been popped out. Then we are not having any input symbol, but the stack top is B. So, but we wanted to have the stack top as capital Z. So the string is rejected. So this is the PDA to accept the language L equal to WCWR. So now let us start the third problem, that is our Turing machine. Open the JFLAP tool, then click over the Turing machine. So let us construct a Turing machine to accept the language L equal to 0 to the power n, 1 to the power n, where n is greater than or equal to 1. That is the minimum string is 0, 1. The language says that the strings has to be like multiple zeros followed by multiple ones, where the number of zeros and number of one has to be same. These kind of strings have to be accepted by the Turing machine. So we will be having multiple zeros and then followed by multiple ones. Let us consider the example as 3 zeros followed by 3 ones. So let us consider construct a Turing machine. So let me have the initial state Q naught. So upon receiving the input symbol 0, it has to transit to the one more state, that is Q1. And let us change the input symbol, that is 0, as X. And let us move to the right so that we can identify the last replaced 0. 0 is the input symbol, and that has been replaced as X, and we are moving to the right. So we are having 0, 0, 0, 1, 1, 1. So the first 0 is being replaced by X. So now we are having two more zeros, and then we are having 1. As we need to have the equal number of zeros and equal number of ones, we need to parse all those zeros till we get 1. So we are continuously, that is looping until we will be getting 1. So we have passed all the two zeros that are after the first 0, which we have replaced as X. So let us change the state from Q1 to Q2, and we are having the input symbol as 1. So let us change the input symbol 1 as Y, and let us move to the left so that we will be again looping all the zeros and ones. So the first 0 and first 1 are being replaced. Like the first 0 is replaced with X, and the first Y is replaced. First 1 is replaced with the Y. Then let us move to the left. So while we are moving to the left, the first thing is like we have encountered with the 0. So we need to move till we get X. So let me have the self loop over 0 as an input symbol, and let it be 0 as itself. And let me move to the left side. So upon looping till we get the X, upon getting the input symbol as X, then we are having the same thing like zeros and ones. So the same thing we have to loop from Q2 to Q0. That is the same thing, zeros and one. So over the input symbol over the input symbol X, let it be X as it is, and let us move to the right side. Let me just relay out this one. Yes. So this self looping and this looping from Q2 to Q0 will be replacing all the zeros and ones. So the second, so let us trace once again. The second 0 will be replaced by X. That's third 0 will be self looped here in the Q1, and then we are having one more Y here, which we had earlier replaced. So we have to have the self loop for the symbol Y here. So the input symbol was Y. Let it be Y as it is, and let us move to the right. So then we got 1. Then we got 1. So we replaced it as Y, and we moved to the left. But when we moved to the left, we didn't have 0. We were having the Y, which was replaced in the first iteration. So let us have a self loop for the input symbol Y, and let it be Y as it is. But let us move to the left side. So this one will be moving to the left. So we passed the first Y, which we replaced in the first iteration. Then we got the last 0, that is the third 0. We passed that one. Then we got X. So we need to move to the right again. So we have got the 0 as the input symbol. So 0, we came to Q1. Then we are having two Ys. So we passed the two Ys by moving to the right. Then we got the last one, which has been replaced as Y, and we move to the left. So we are having two Ys here, which we have like passed them. So then we got the first X. So upon parsing the X, we are having the next input symbol as Y. But so till now we have replaced all the three zeros followed by three ones. So we are not having a transition symbol for the input symbol Y here. So as we have traveled like all the all the 3 zeros and 3 ones, the string has to be accepted. So we are designing the machine in such a way that after receiving the blank state, the string will be accepted. So we are now the input symbol is y. So let me have one more state q3. So we are having the first y here. So first y, let it be y as it is, and let us move to the right. So we are having multiple y's here. So let me have one more state q4. For the q3, the multiple y's will be looped there. So we have got the so we have moved till the last character, that is the blank space. Let me just relay out this one. Yes, we have come here. So let us have the one more state q4. So upon receiving the blank space, let us just be there, and we'll be moving to the right, the blank space. The q4 will be the final state here. So this is the Turing machine to accept the strings, that is the language 0 to the power n, 1 to the power n, where n is greater than or equal to 1. Let us test with some of the inputs. For the input, let us give the same input, that is 3 zeros followed by 3 ones. So initially we are having 0. This one will be replaced with x. Then we are having 2 zeros, which will be passed with the q1. And the first y will be replaced with y. Then we are traversing back. Then we are having 2 zeros here. Let us traverse back. So then we have got the x. Then we need to move again to the right side. Now the 0 will be replaced with x here. Then we are moving to the right. The 0 and y will be passed with state q1. Then we have got the input symbol y1, which will be replaced with y, and we are moving to the left. The input symbol, we are having y and then 0, which will be parsing. And then we are having the input symbol x, which takes the state from q2 to q0, and it will be like looping. So next we are having the input symbol 0. It will be replaced with x, and then we are passing the remaining y's with the state q1. Then we have got the input symbol 1, which will be replacing with the state y, and then we are moving to the state q2. Then we are having multiple y's while we are moving to the left. Then we got the x, but the next input symbol is y, but we are not having a transition from q0 to q1 on the input symbol y. So that so till here we have replaced all the zeros and ones with x and y. So we just have to traverse all these y's in order to reach the blank space, so that the string will be accepted. We are just traversing all the y's with the state q3. We have traversed, and we have got the blank space here, which will be accepted by the state q4 as it has reached the final state. So then let us check for one more input symbol. Let me give 2 zeros followed by 1. So the initially it is 0, which will be replaced with x. Then I am having the 0 as the input, which will be just parsed, and the first one will be replaced with y. So then we are moving back, that is to the left. So we have got the input as x, then it is a loop. So we will be just moving from q2 to q0. Then the input symbol is y, 0, which will be replaced with x. Then the input symbol is y, which we are just traversing to the right. So, but after traversing, so we have got the blank space here, but q1 is not having the transition over the blank space, so it has to be rejected. So the string is rejected here. So this is what the Turing machine to accept the language L equal to 0 to the power n, 1 to the power n, where n is greater than or equal to 1. So the last problem that we are doing today is Parse trees, that is the derivations. So let us open the JFLAP tool and click on the grammar. And let me just give the productions here. The LHS is capital S. Then the RHS, it gives the productions like capital S, B, S. Then the next production is capital S gives A. So let us, this is the grammar. So let us test the for the parse trees, brute force parse, you just select, and let me give the input as A, B, A, B, A, B, A. So let us check for the parse trees. So let me just zoom this one. So here you just give start. So the initially the starting state will be yes. So we are having the input. We have to construct the parse tree for the string A, B, A, B, A, B, A. So if we select the S gives A as the initial state is A, we can't move further in order to get the other characters. So let us check the, let us have this production S gives S, B, S, so that we can try out with the other. So we use the production S gives S, B, S. So we are having S gives S, B, S. So B is there amid here. So now for the next state, the first yes we are replacing again with yes, B, yes. So let us check once again. So last uh, uh, yes, we are again replacing with yes, B, yes. As we have got here three B's, B, 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 we are replacing here. So if we replace these yes with yes, we can get. So like let us check. The first yes is replaced with A. Again, the second S is replaced with A. So we have got A, B, A, and here B. So we need to have A, B, A again at the last as the last three characters. So if we replace these two S with S, then we will be deriving our actual required string. So this S is being replaced with A, and then this is being replaced with the character A by using the production S gives A. So that is the parse tree and the derivation for the string AB, AB, ABA using the productions S gives, S, B, S, and S gives A.